let's take a look at a quick recap of what we did in Chapter 5, sections 1 through 3. So first of all, to determine if a number is even, it has to be able to be written as 2 times a whole number. So, for example, the number 12 is even because it can be written as 2 times 6. If it's an odd number, it's 2 times a whole number plus 1. So the example could be the number 7 is odd because it's written as 2 times 3 plus 1. Another way to think of even and odd is through skip counting, or with an array. An even number would have a rectangle. An odd number would have a rectangle with some extra blocks or squares to the side. Okay, now let's talk about divisibility tests. So we're going to look at this number, 7,491. And I'm going to make a list here. So this is going to be for number 3. All right. 2 does not divide 7,491 because of the last digit not being 0, 2, 4, 6, or 8. So that one doesn't work. 3 does divide 7,491. And the reason is if I add the digits 7 plus 4 plus 9 plus 1, I would get 21. And we know that 3 is a factor of 21. So what we're doing is we're checking the sum of the digits and see if the number we are testing, the 3, is a factor. So that one is a yes. Okay, and this one is a no. All right, so let's keep going with our tests in order. Next test is for 4. So if I want to test divisibility by 4, I look at the number 91. So I make a 2-digit number out of the last 2 digits and see if that's divisible by 4 without remainder. And that is not the case. All right. So 91 gives us a remainder when we divide by 4. So this cannot be divisible. 5 is pretty easy. You just look at the last digit. We have a 1. To be divisible by 5, it has to be a 0 or a 5. We don't have a test for 6 or 7, but how about 8? All right, so for 8, we're going to look at the last 3 digits of the number, and I want to know if this division would give me a remainder. And actually, it really does. So, not divisible. All right, so this is no, no, no. So far, only divisibility by 3. We have 9, 10, and 11 to check. All right, so 9. And the good thing about 9 is it's the same type of test as 3, and I already know the sum of the digits. So I want to say, does 9 divide 21? So what I'm doing is I'm reusing that 21 from up here. And that is not true. So not divisible. 10, a super easy one also. You look at their last digit. If the last digit is not a 0, it can't be divisible by 10. And then 11. All right, so 11's the one we talked about in class today. What you do is you add the even and odd positioned digits. So like 7 and 9 would come first. So I add them together. And then I'm going to do the same thing with the 4 and the 1, but I subtract those 2 sums. So add the position digits, subtract those. So that's going to give me what? 16 minus 5, which is 11. Okay, this answer has to be a multiple of 11, which it is, right? 11 is a multiple of 11. Because 11 times 1. So the answer here is yes. So the only ones that work as factors are 3 and 11. Okay. Number 4 and number 5. 0 and 1. Those 2 numbers are not prime and they're not composite. They do not fit our definitions. Prime is a number is only divisible by 1 in itself. Composite has other divisors also. So 0 and 1 are not prime and they're not composite. Now, prime factorization. And I'm going to use, I couldn't decide what number to use here. Let's use this. I'm going to use 3,465. So I want to write a prime factorization I'm going to use a factor tree. And immediately I know it's divisible by 5. It would be nice if it was divisible by something a little bit larger. Let's try, I'm going to try 9. So does 9 divide 3465? And the way we would figure that out is 3465. Add those together. That'd be 18. 9 does divide 18, which tells me I have a factor. Now, I just chose 9 randomly. We could choose other numbers, but I do need to know what the other factor is. So let's see. 3 times 27. 6, that's going to be an 8, and then a 5. All right, so one option is to write 3,465 as 9 times 385. Now, 9 is not a prime number. This one's not either, so we're going to keep going in our factor tree. Now, the good news is, on the left, we're down to prime numbers, so I don't have to worry about that one anymore. Let's work with 385. We know it's divisible by 5. The other factor, 5 times 7 is 35, is 77. Okay, so this is looking good because we have a prime number, and then the factors that are prime of 77 are 7 and 11. So the prime factorization of 3,465, I use the numbers at the bottom of my factor tree. 3 squared because there are 2 of those. And then sometimes we'll use this multiplication, like the X symbol for multiplication. Probably more common in your lower grades just because they're not used to that dot for multiplication. So either one. So there's your prime factorization.